Welcome in .Core. On October 9th, 2022, astronomers detected the most powerful gamma-ray burst ever, GRB 221009A, nicknamed the brightest of all time, BOAT. It releases more energy in seconds than our sun will in its entire lifetime. This burst saturated detectors and even affected the Earth's atmosphere. Using the largest telescope LST-1 in La Palma, Spain, researchers have now uncovered new details about its jet structure, challenging long-standing theories. In this video, we'll dive into what made the BOAT so unique and its significance for future astrophysics. The discovery, catching the BOAT GRB 221009A, immediately stood out from every other gamma-ray burst on record. Detected by NASA's Fermi and Swift spacecraft, the burst traveled around 2.4 billion light-years before reaching Earth. For comparison, that's roughly one-fifth of the observable universe's age and distance. Its intensity was unprecedented. The burst was estimated to be about 70 times brighter than any previously observed one, making it a once-in-10,000-year event. This is why astronomers began referring to it as the brightest of all time, the BOAT. Like most long-duration, this one was likely caused by the core collapse of a massive star. At the end of its life, the star's core collapsed into a black hole while its outer layers were expelled in a supernova explosion. In the process, a pair of relativistic jets, beams of plasma moving at nearly the speed of light, were launched into space. When one of these jets happens to align with Earth. But GRB 221009A wasn't just bright. It also produced multi-TF gamma rays with some photons reaching energies around 18 V detected by China's Lechiso Observatory. This far exceeds what is typical for these, raising questions about how particles in the jets reach such extreme energies. The BOAT didn't just affect telescopes. It briefly disturbed Earth's ionosphere, altering how radio waves propagated in the upper atmosphere. That's rare for a deep space event, and highlights the scale of this explosion's power. After the initial flash, telescopes tracked the afterglow across X-ray, optical, and radio wavelengths for months. The large-sized telescope LST-1, part of the Cherenkov Telescope Array, CTA, observed a fading high-energy signal starting 32 hours after the burst for 20 days, providing crucial data on its structure and behavior. Scientific importance and new insights. GRBs are often described as natural laboratories for extreme physics, offering a chance to study relativistic jets, particle acceleration, and black hole formation. Yet, despite decades of research, their internal structures remain poorly understood. For years, its jets were modeled as simple top-hat structures, uniform cones of energy with sharp edges. But the BOAT's high-quality data challenges that view. The LSD-1 team detected a subtle excess in high-energy gamma-ray flux that didn't match predictions for a top-hat jet. Instead, their findings support a structured jet model. In this scenario, the jet has layers, a fast, highly energetic core surrounded by a slower, less energetic sheath. This layered structure better explains the observed afterglow and provides insight into how particles in the jet achieve such extreme energies. It also suggests that the central engine, likely a newly formed black hole, drives these outflows in a more complex way than previously thought. Another intriguing aspect is the survival of multi-TeV photons over such a vast distance. Normally, high-energy photons interact with cosmic background light and are absorbed before reaching Earth. The detection of these photons implies that either it was unusually efficient at producing them or that our understanding of how intergalactic space attenuates such high-energy light needs revisiting. These findings also strengthen the connection between GRBs and ultra-high-energy cosmic rays. The BOAT's particle acceleration seemed consistent with processes capable of generating some of the most energetic particles in the universe. Perhaps most importantly, this event offers new context for how long these have behaved. If structured jets are common, it means past data may need to be reinterpreted. This also impacts simulations of how massive stars die, how black holes form, and how their remnants interact with their surroundings. What's next? Future observations and big questions. The study of GRB 221009A is far from over. Its brightness and proximity make it a benchmark event for future research. How typical are structured jets? One major question is whether this layered jet model applies to most GRBs or if the BOAT is an outlier. Future events will need to be observed with the same level of detail to provide a clear answer. What role does it play in producing cosmic rays? If these explosions can accelerate particles to multitages, they may contribute significantly to the highest energy cosmic rays detected on Earth. Can multi-time astronomy unlock more answers? While no neutrinos or gravitational waves have been directly tied to the boat, future events could provide these additional signals. Detecting them alongside gamma rays would give an even clearer picture how these explosions work. Looking ahead, new instruments will be crucial. The CTA, an array of telescopes being built in both hemispheres, will have higher sensitivity and faster response times, enabling earlier and more precise observations. Meanwhile, continued multi-wavelength monitoring with radio observatories, X-ray satellites, and even the James Webb Space Telescope will help refine models for how afterglows evolve and how jets interact with their environments. The boat also underscores the importance of global collaboration from NASA's spacecraft to ground-based facilities in China, Spain, and beyond. This burst was studied by an international network of scientists. Future coordinated campaigns will be key to capturing and decoding these rare fleeting events. Ultimately, these remind us that our models of cosmic explosions are still evolving. Each new observation brings us closer to understanding how the universe's most extreme events unfold and what they can teach us about the life and death of stars. Outro GRB 2210009A, the brightest of all time, is reshaping our understanding of gamma-ray bursts. From its massive energy to its newly uncovered structured jet, the boat challenges old theories and offers new insights into star collapses, black hole bursts, and high-energy events. As next observatories come online, it will be a key benchmark in studying the extreme physics of our universe. Stay tuned for more discoveries in the high energy. Thanks for watching Dark Core.